Yes, in part A, we have said you can use a PDF to find the probability precedence of A is also equal to X is also equal to B from capital F of B minus capital F of A. And because we are dealing with the continuous random variables, even when this is strictly less, the logic does not change there. Even if it was less, we would still find it as capital F of B minus capital F of A. In part B, we have said that you can use the CDF to find the PDF. That is when you differentiate the CDF once. In part C, we can use it to find the median. And we have said that if you want to use it to find the median, then capital F of M must be a half. So to get the interval that we use to get the median, it will be that interval whose capital F of X is at least a half, as we are going to see in the example. Now we were on part D, where we are saying that the CDF capital F of X can be used to find the values of some unknowns. So if your CDF has more than one unknown, then you can adopt the values at any point. The unknowns we are talking about are the constants in the CDF which are quoted. So we can use the CDF to find the values of some unknown constants. So it is at that basis that we are saying that please, the values, we are noting under that. We are noting under using the CDF to find the values of the unknowns. We want to note and say that the values at endpoints are very, very important. If you want to find the values of some unknown constants, then the values at any points are very important. So if you meet any CDF and it has some unknowns, unknown constants, then the very first thing is to think about how do you use the values at endpoints to find the values of those unknowns. So in our example, like we said, we are adopting to move from the PDF first and we get the CDF. Then we shall later move from the CDF and then we get the PDF. You will note that the PDF calculates whatever we have discussed, but the CDF cannot be used to calculate the mean, and therefore it can't be used to calculate the variance and also the mode. So it can only do what we have quoted in the uses, but also the quartiles, the percentiles, and deciles can be calculated using this because their knowledge is similar to that of the median. So if they tell you to calculate the mean, the mode, the variance, then you must first convert the CDF, the PDF, and you calculate accordingly. So in our example, we are moving from a PDF to a CDF, and we said if you want to move from a PDF to a CDF, then you have to integrate. We are going to see how you do that integration. So in example 1, we are saying a random variable capital X has a PDF small f of x given by our small f of x is given by, so our small f of x is equal to 1/8x. This is when our x lies between 0 and 4, and it is 0 elsewhere. So required is to find, this is part A, find the CDF, capital F of x, and you sketch it. Then part B is to find the median, normally 1, the median. Then normally 2, we need the probability 0.3, this is equal to x, this is equal to 1.8. Yeah, that is going to be our exam. Now, in some questions, they may not say that this PDF is for either a continuous or a discrete. They may just say that random variable x has a PDF given by this one. Now, if that happens, look at how these values have been aligned. If it is an interval, then it means the random variable being talked about is a continuous random variable. And if it is if there are values which are just listed independently, then it means the random variable being talked about is a discrete random variable. Also, some questions may not say that this is a PDF or a CDF. They may say the random variable x has a probability function given by this. Then if that happens, then it will imply that you look at this one. If this is capital F, it means the function is a CDF. They may either use capital F of x or probability. They may use capital F of x or probability. Capital X is less equal to small x, and they say it's equal to something, so it will imply that this one is a CDF. And if they use a small f of x, like it is here, then it means it is a what? A PDF. So they may not say it is a PDF or a CDF, and they simply say that it is a probability function. But how this has been written dictates what this one represents. It will either represent a PDF or it will represent a CDF. Now, in this case, they have already told us that this is a PDF, and because this is a range of values, it means this PDF is for a continuous random variable. So a random variable x has a PDF small f of x given by this. We want to part A, find the CDF capital F of x, and then we sketch it. So these are the procedures of finding the CDF capital F of x. Our function is simple, it has only one interval, so it is the one that we are going to start with. Now, if you're given a CDF, if you're given a PDF small f of x and you're supposed to find its PDF, its CDF, the very first step is to draw a number. So in our solution, you draw a straight line, a straight horizontal line. After drawing that straight horizontal line, we are on part A of finding the CDF capital F of x. You go to the PDF and you pick all the values on the intervals that are given. We have only one interval and it has a 0 and a 4. So you begin with the list. The list is a 0. The highest is a 4. After putting those values there, now you use this variable here to define the intervals. That will be no CDF capital F of X. We shall have the values because it is cumulative. It must account for all the probabilities on this number line. So we shall need the probabilities of all X values which are less or equal to 0, because all these values are less than 0. We shall need probabilities of all X values between 0 and 4. We shall need probabilities of all X values greater or equal to F4. This is the X is greater or equal to 4. This is X is less or equal to 0. This is between 0 and 4. And we are going to see how we generate capital F of X in this interval before, in the interval between, and in the interval after. Now our PDF is only defined in the interval from 0 to 4. And because it is a simple one, we are going to first deal with the interval from 0 to 4. Then we shall see how do you use this interval to get the capital F of X of this part, and how do you use this interval to get capital F of X of the other part. So we are beginning with after getting the intervals in which the CDF is going to be defined, then you start with this one. So for the interval from 0 is less or equal to X, less or equal to 4. Our small f of x is defined as 1 over 8. X, this is when x runs from 0 up to f4. Now after quoting the function and the interval, you suppose you let any other variable represent this, because we are going to look for capital F of x. We want that x to really phase out and denote it with some other thing. Then we shall bring it back as a result of integration. So we are going to let small f of t to be small f of, we are letting small f of x to be small f of t. And if small f of x becomes small f of t, remember small f of x is 1 over 8x. So if it is now small f of t, it will be 1 over 8t. Where there is x, you put there a t, and it will now run from 0 is less or equal to t, less or equal to f4. Now after converting the x to a t, now if you want capital F of x of any particular interval, when you integrate from negative infinity up to x, and you integrating f of t with respect to t, you get its capital F of x. Our x is going to come back as a result of replacing it after integrating this with respect to a t. So my capital F of x is now the integral from negative infinity to x. Where there is negative infinity, you remove it and you put the lower limit of the interval. Where there is small x, you maintain it. So our capital F of x is going to become the integral. Where there is negative infinity, remove it and put a 0. Where there is x, you leave it there because you want to be replaced where there is this after integration. Where there is f of t, you remove it and you put this. So our f of t is now 1 over 8t dt. So that is going to give us our capital F of x. So 1 over 8t, 1 over 8 is a constant, you pull it out. We now have the integral from 0 to x of t dt. That is our capital F of x. So our capital F of x is going to become 1 over 8. What we get when we integrate a t? We get a t squared over 2, but we have integrated from 0 to x. So our capital F of x will become 1 over 8. Put in the upper limit, we are going to have, where there is t, put x, we shall have x squared over 2. Then put in the lower limit. We said these lines, the line signifies that you're done with putting in the upper limit, and now you want to put in the lower limit. We are going to have a 0 squared over 2. So my capital F of x will definitely become, it is the 1 over 8. This one is the 0. So it is 1 over 8 x squared over 2. And my capital F of x is now going to be x squared over 16. So that is the capital F of x for the interval 0 is this equal to x, this equal to f4. Now I will quote it and say my capital F of x is x squared over 16. This is when x lies between 0 and f4. Now if you want to get capital F of x of this first interval, you get this 0 and you substitute it in the capital F of x of this one. If you want to get capital F of this, you get f4 and you substitute it in the capital F of x of this middle part. If they were 3, the logic wouldn't change. But we are beginning with a simple one. So after getting the CDF of the middle part, you get this value here, which is a 0, and you substitute it here. You get the capital F of x of this interval. After getting the capital F of x of this middle interval, if you want the capital F of x of the last interval, you get this, and you substitute it in the capital F of x of the middle interval. You get the capital F of x of the last interval. So we are going to have our capital F of x is the x squared over 16. This is when x lies between 0 and 4. Now we want for the next interval, for the interval x is equal to 0. For this interval, which is for x is equal to 0, you have found this and you say you get this, and you substitute in this one. You get this one, you get this, and you substitute in this capital F of x. So our capital F of x of the middle interval is this. Now we are going to use this and you get the capital F of x of this one. So we are picking a 0. We get a 0 and we substitute in this to be a 0 squared over 16, and capital F of 0 becomes 0, which means capital F of x is a 0 for the interval x is equal to a 0. We are now done with this and this. If you want this, capital F of this, you get this and you substitute in the capital F of this one. So our capital F of the middle part was this. If we want the capital F of x of the last interval, we get this value and we substitute it in the capital F of x of the middle interval, which will be a 4 squared over 16, and capital F of 4 will be a 1. So our capital F of x is going to be a 1 for all values which are greater or equal to a 4. Now, after getting the capital F of x for all the intervals, we can now say that the CDF capital F of x is going to be our capital F of x. Remember, it was defined for 0 and 4. We have an interval of x is greater or equal to 4, an interval between 0 and 4, and an interval for all of x values less than 4. So our capital F of x becomes, we start with the first interval. It was a 0. It is a 0. That is when x is less or equal to 0. We go to this next interval. It is the x squared over 16. This is when x is between 0 and 4. We now go to the last interval. It is a 1. This is when x is greater or equal to a 4. Now, if it is a CDF, it does not possess 0 elsewhere, but rather it has a 1 for the last interval, and in most cases it is a 0 for the first interval. Now, having obtained the CDF, our question was saying that after getting the CDF, you please sketch it. Now we are on the sketch of capital F of x. Now, for the sketch of capital F of x, we follow the same procedures as those of sketching the PDF. So you identify the CDF, the different intervals. I'm going to identify it for the first interval. So my capital F of x is a 0. And this is when x is less or equal to the 0. Then the next step will be identifying whether f of x is linear or non-linear. My capital F of x is equal to 0. This 0 is a constant, which means that capital F of x is linear. So my capital F of x is equal to 0 is linear. And because it has only one endpoint, which is a 0, we don't need to find the values at any point because it has only one endpoint. But we shall just draw a straight line for all the x values that are less or equal to a 0, and we shall end at when x is exactly a 0. So there is no need to find the values at any point because we have only one x coordinate. That line will stretch from all the x values and end at a 0. The next one is the capital F of x is equal to, for the next function, we are identifying f of x in different intervals. It is this for this interval. It is this one for that interval. So it is the x squared over 16 for the interval where x runs from 0 to 4. Now you ask yourself, is my capital F of x linear or non-linear? It is non-linear because it has a square on x, and since it is non-linear, we need the values at any points. Why find the values at any points? Because it has a starting point and some other extreme coordinate. So it is going to start when x is 0. So when x is 0, and it will end when x is a 4. So when x is a 0, we put this 0 in the original function. So our capital F of 0 is going to be a 0 squared over 16, and capital F of 0 will be 0, which means the point to plot becomes 0, 0. When it is a 4, capital F of 4 becomes a 4 squared over 16, and our capital F of 4 will become a 1. So the point to plot is a 4 and 1. So it means our nonlinear CDF list is going to start when at 0, 0, and it will end at 4 and 1. Now, since this is nonlinear, we shall also need to find the turning points for that CDF. We are now heading for the values. Having found the values at endpoints, we are now heading for the turning points. So we are going to come here and now say the turning points for that nonlinear part of the CDF. Now, our turning points, we are saying capital F of x is x squared over 16. But at the turning point, the first derivative must always be a 0. So at the turning point, capital F prime of x should be a 0. And if f of x is x squared over 16, it means f prime of x would be the first derivative of this. So you drop a 2 and reduce the power by 1, which now becomes 2x over 16, which is as good as x over 8. That is our first derivative of our nonlinear CDF. Now, where there is f prime of x, remove it and you put x over 8 is equal to 0, and your x will be a 0. Because we need the turning point, when x is 0, we said that now this time our coordinates are going to be in the form x, comma, capital F of x. So we have this, but we need this. So our capital F of x is the x squared over 16. Capital F of 0 is going to be a 0 squared over 16. And capital F of 0 is a 0. So our turning point, which is x, comma, capital F of x, will now become 0, comma, 0. So our turning point is a 0, 0. So that's nonlinear CDF. So my turning point is a 0, 0. Now I need the nature of that turning point, having obtained it using the first derivative. The first differentiate nonlinear function once, equate the derivative to 0 to get the x coordinate. After getting the x coordinate, substitute in the original function to get the y coordinate, which is now the capital F of x coordinate. It was a 0. Then finally, you write your turning point. We are now in the nature of our turning point. It is only one. So we are in the nature of the turning point, capital T, which is a 0, 0. To get the nature of the turning point, we say you can use a table. If not a table, you can use the second derivative. So our capital F of x was x squared over 16. The first derivative of that was 1 over 8x. Now f double prime of x is going to become 1 over 8. second derivative, we say you get the x-coordinate of the turning point and you substitute it in the second derivative. If the result is greater than 0, it is a minimum. If the result is less than 0, it is a maximum. And if it is 0, it is a point of inflection. But most of the points that we deal with, they are either minimas, maximas. So my turning point is a 0, 0. I will get this x-coordinate and substitute there. So f double prime of 0 is 1 over 8. We don't have anywhere to put this x-coordinate because this thing is a constant. So f double prime of 0 is a 0. So since f double prime of 0, which is 1 over 8, is greater than 0, then our turning point, which is 0, 0, is a minimum. And therefore it is a U-shaped. That one is a minimum. And therefore it is going to be U-shaped. Because when you go to the second derivative and we substitute in the x-coordinate of the turning point, we got a value which was greater than a 0. So after getting the nature of the turning point, we also said that you may or may not find the intercepts, but let us find them.